distance measuring equipment, AIM-117. Alright, so how it works, we have a ground station, like so, right here. Right? I'm just going to actually start from the plane. Your plane has a receiver and a transmitter. The DME station also has a receiver and a transmitter. Your plane is going to ping off a signal. Right? That signal is called the interrogation. That signal interrogates this DME station right here. The DME station replies to your plane. So, in summary, interrogate the DME station, DME replies. The time difference it took from when your plane interrogated the DME station to when it got the reply, you can calculate for distance using the speed of light and all that stuff. Math, right? So that's how DME works. Very basic. Something too fancy about this. You can pair DME up with VORs. You can call it VOR DME. You can also pair it up with TACANs. We can call that Vortax or TACANs by themselves. You can also pair it up with localizers, localizer DME, right? Either way, it still works the same thing. Interrogation, reply, distance. What the thing actually reads though, so we'll call this the ground distance between the plane and the DME station. But of course we're going to be at altitude. Right. There you go. Nice little triangle. Alright, so you would think we'd be able to get the x distance, the horizontal ground distance, but no, that's not true. DME gives you the slant range distance, which is the straight line distance between your aircraft and the DME station. And this can bring us some issues. This is the biggest and major issue of DME. It means that if you were to fly over the top of the DME station, right, all you're going to read is the vertical distance, even though the horizontal distance is 0. It's your true distance from the VOR, or the DME rather. DME is going to be read in nautical miles, so it's pretty easy to interpolate this. Every nautical mile is roughly 6,000 feet. I think exactly it's like 6,078 or something like that, but we'll call it 6,000. So if you're 12,000 feet here, fly over the top, right, this should show 2 miles. If you're at 6,000 feet, it should show 1 nautical mile, right? So slant range isn't going to necessarily fool you every single time. There's a rule of thumb to pay attention to. It's the 1-to-1 is what I call it. It's actually 1 to 1,000. So for every 1 mile, you have 1,000 feet, right? Within that bubble, you're going to have a lot of slant range error, meaning your range isn't going to be very reliable. But let's say you're at 1,000 feet in 2 miles. You're still good. Another example, let's say 5 miles. You want to be at least 5,000 feet. 5,000, 5 miles. So, inside of this, so within the 5 mile range at 5,000 feet, more slant range error, because obviously there's more height than there is distance. Outside of this 5 and 5, less and negligible slant range error. Same thing goes 12, 12, 10, 10, stuff like that. So obviously in most GA aircraft, there is not a physical DME receiver or transmitter inside the plane. In that case, we're going to use GPS. What makes it legal to substitute GPS in place of DME is you actually read AIM 1-2-3, which we'll cover later in one of the other GPS lessons. But if you're using GPS DME instead of actual real DME, which is pretty old, GPS DME will actually give you the horizontal distance to your station, so it eliminates the whole need of slant range error.